All right. With that said, are there any questions that you want me to go over on this exam?
I was just thinking the perpendicular and parallel one, the last question.
Sure. This one here, number 8.
Yeah.
You weren't required to put in any kind of form. You could put it in any form you wanted to. But first thing you need to recognize is this right here. Okay, if the line is parallel to that, that means its slope is the same. That means the m that I'm going to use on this line will be 5/3. Now perpendicular, what would the m be that I'll use there?
-3/5.
-3/5, the negative reciprocal. You can practically use them side by side with each other. I'll show you. Part A, m is going to be -3/5. Part B, m is 5/3. So a preliminary answer for each of these, this one here would look like this. And we have to figure out the letter B. This one will look like this. But I'm going to find out that letter B. How do you find out the letter B? You remember what the process is?
You put y and x in the points.
That's right, these are points, the point you're given. You're given an x value. All right, and you're given a y value. So I can replace x and y with those numbers, so y is replaced with 2. And x gets replaced with 5. This is going to allow you to figure out the value of b. Same thing over here. The left one is a little bit easier because the 5 and the 5th cancel each other out. So the one on the left is a little bit easier. I can cancel this 5 here. Now I get 2 equals -3 plus b. And so b is going to equal 5. So part A, my answer then is that y equals -3 fifths x plus 5. This is the formula we put it all in that slope intercept form, but you aren't required to do that here. This one here doesn't simplify so well. Here we get 2 is equal to 25 over 3 plus b. Now to prepare for the subtraction I want to do, I'm gonna write the left side as 6/3. That way, when I subtract 25/3, it's ready for me. That's not the answer there. That's just me. The actual answer then is y equals 5/3. Y equals 5/3 x minus 19/3. Okay, other question? Probably you'd like me to do on this test. That's all I did. That's all you need.
Maybe number 7.
Number 7.
Number 7. I don't know if I need all that. It's just that's good enough. All right, so this one here, slope and y equals, let's start with the slope. The slope is, remember, that's rise over run. So when you do the slope, you can do it on here. You can either use the formula or you can simply start on the left one and count. So if I want to go from this point to that, but I can only go side to side and straight upward. Tell me how I would start to go from here to there. Tell me how I would do it. 1, 2, 3, 4, 5. So you went up 5. So the slope is 5 over something. Now from this point, how many to the right did you go from there? 1, 2, 3, 4. Right 4, that's what goes down here. Now for the second part, you know the thing looks like this. Y equals 5/4 x plus b. Now what can you do with this at this stage? You gotta figure out what b is. So I already know what most of this is gonna look like. And I need to put a b there, yeah. So how do I get it? How do I get the b? Or what we just did in the last problem. Remember, I plugged in the point. You have 2 points available to you. Which one's easier? I don't know. This is 1, 1. I'll use 1, 1 on that. You can use that one, you get the same answer either way. So that means I'll replace y with 1, and I'll also replace x with 1. So I get 1 equals 5/4 plus b. I'll subtract 5/4 from each side.
Let's see if you can hang with me on this. What it ends up being is B equals -1. Other questions on this test?
I don't like, you're gonna need it you're gonna need the knowledge that we had on that test for what we're going to do, because we're just going to extend, well, I don't say extend on it, we're not gonna do anything new. In some sense, we're gonna still graph. But, yeah, just to let you know, this next test will involve graphing as well. And lines.
Other questions? Don't be afraid to ask.
Well, should you go and do your research on the solutions, you know they're up there. Does anybody, I have a couple of blank ones. Does anybody want them for study purposes? Okay. I guess I'll remind you too, that you can improve any test score when you do the final exam. You said you wanted one? You want? All right, then I'll go ahead and start the new material. Don't want this. See what they have us doing today. I think we're doing. Today we are doing. It's the 26th today, 5.1 and 5.2. All right. Where's the? There it is. We'll jump back into 9.3 for the second half of it later on, but we need to do something here first. Oh, let me grab the name first before I do anything else. Okay, that sounds like a good place to start. Okay, the question, I better grab the description of the question too. That's this thing, this determine whether the ordered pair is a solution to the system of equations. And let's talk about what all this stuff means. All right, we're going to be drawing, the first thing we're going to do is we're going to be doing a graph, and we're going to graph two lines on the same graph. What we're looking for is the place where they intersect each other. So you'll have two lines. You can just imagine one going this way, say one going this way. They'll cross somewhere unless they're parallel. You understand? If they're not parallel, they'll cross somewhere. That's what the goal of this chapter is to figure out where they cross. So let's do this problem. When they say an ordered pair is a solution, that means I can take and plug in x equals -1 and y equals 3, and it will work in both equations. Watch what I mean. So if I take this equation here and plug in these numbers, so y is supposed to be 3 and x is supposed to be -1, is that true?
Yeah.
The left side is 4 and the right side is 4, isn't it? Double negative changes to a positive. It's 3 plus 1 over here. So it works in the first one. It also has to work in the second one as well. So I'll replace x with -1. I'll replace y with 3. You only need to go so far until you can tell it really is true. Would you say this also works? This is equal to 8 over here also, isn't it? You can go one more time. Let me graph these two things. I'm gonna have to change my background. Yeah, that's pretty good. All right, let's start here with y minus x equals 4. What would you do in order to make that thing graphable?
Solve for y.
Right, in both cases, solve for y. So when I look at the first one, y minus x equals 4. Y minus x equals 4. If I add x to both sides of this, I'll get y equals x plus 4. Do you agree with that? What's the slope of this line, by the way? 1. No, it's not right. Just move it up to the top right. So technically, there's a 1 on it. After that, when we work the second one, x plus 3y equals 8. This is the problem. I'll solve it here. I'll subtract x from each side. And then I'll divide by 3. Of course, this one has a bad y-intercept. 8/3 is about 2 1/3. Move speed. Not exactly on this one. And the slope is -1/3. That means you go down 1, you over. We connect those with a line. So there's one. Now the second line, remember I'm estimating, I wanted this to come out well, but it did not. Can I pull this over to the side? The other one was pretty simple, x plus 4. So let me Draw that one in. So the line that was x plus 4, the slope is 1. So x plus 4, I go up to 1, 2, 3, 4. Here. And then the slope is 1, so it's just that. I think I need to extend that other line though. I'm going to extend this one a little bit so I can see where they intersect each other. Well, you can see because my graph is a little bit off, the point of intersection was meant to be here. You understand? If I'd estimated this better, probably a little bit up, I'm guessing. Let's do that. I think I can fix it while I'm here. I'll just rename that spot, that's all. Right, but anyways, the thing we're looking for is this guy right here. This point is exactly that. Okay. So we're gonna graph two lines on the same graph, find where they intersect. That's the goal, okay? Are you guys with me? Now, these things turn out to not be completely simple to make them up off the top of my head, so I'm gonna grab some out of the book that are, I hope, guaranteed. Well, I should probably fix that side too, huh? Yeah, I think. There we go. All right, so let's grab a problem out of the book. See how you do with it. I just want you to solve. I want ones that have, let's try number 12. Let's start with that. So they're both in slope intercept form. This hopefully is the easiest one. Who needs straight edge? Who needs paper? You need both?
I see paper.
Paper, okay. Bag here.
Same page.
Just. When you did the preview, see the intersection.
Remind you. The first one. Well, I'll do the line, then you can see if yours matches mine. I get it started at this place here, if I can get that settled. The slope is 1/2, so that's up 1 and to the right 2. Put it way over here. You can count too. Like I can go up 5 so long as I go over 10. I can reverse myself here. I think that's the spot. We draw a line connecting them. That looks good. Now the other line, let's take a look at that one. Here I'm going to start at the y at -1. I have no idea what that just tried to do. Oh, annoying. All right, so this one, -1 down here. And then its slope is rise 2 to the right 1. So I go up 2 to the right 1. If you look out like this one, you'll see it right here. Look, up 2. Right here is going to be the intersection point. You see it?
Yeah, I get it.
So once you get that, I mean, there's no sense in going through a lot. Once you find the place, just be done with the thing, So I'm not going to bother doing much else here, just to sort of illustrate what I did do. Let me get a line through those things. Get in there, you. Battlesby. So there's our intersection point. We have, what is the location of that point? What are the coordinates of that point? 2, 3. Let's get that in there. Now, so that's our answer, is 2, 3. Let's check it. So when I check it, I should be able to put that solution into both equations and it works. That means I replace X with what value over there? I'll say that again. That was with the question mark, in case you guys didn't know. I'm gonna replace X with what value? 2, and Y with what value? 3. So let's start with the first one. That's Y was equal to 1/2 X plus 2. Now, you don't have to go all the way here, just enough till you're certain it's going to check out. You'll notice what's half of 2? 1. So we get 3 equals 1 plus 2. Is that true? So the first one checks. So I checked this one. Now let me check the next one. This time I'll replace Y with 3 and X will be replaced with 2. You don't have to go all the way, just enough until you know that it's for sure going to work. Would you say that is also a solution on the second equation as well? So it all checks out, right? So my equations check out, and there's my solution. The intersection of things that you graph is very useful and used in a lot of places. I don't know if any of you will go into economics or anything, but you probably heard of the supply and demand curves intersecting in a certain point of equilibrium. Things that, well, you'll run into them if you go that route, but they're used in everything. Graphing is well, every science graphs things just to get a look at what they're dealing with. Are we okay? Can I move off this one? All right, let me give you another one. It doesn't really do much here. All right, let's do. Page 18. So same instructions, graph and find the intersection point.
Wait, and slope intercept. How are you trying to do it? Yes. Black and white. Mhm. When you solve for y, these are the two things you could have got. But you've got to do that before you can graph anything. Let me grab a thing here. Let's put it out there, I guess. All right, let's start with the first one. In this first line here, where should I put my initial dot? Right here, 0, 2, right? Now, how should I move it from there? Uh-huh,
Over, go over one,
uh-huh,
over to two, to the right.
to the right, 2, right? That's good enough for me, I guess. Go ahead and draw a line through those things. And one down. Right now for the second one, tell me where I should lay my initial dot down. So go down 3, right? Go down 3. 1, 2, 3. All right, got it. Now how should I go?
Over to the negative, over to the left,
You don't never go, no,
I mean, what is that, 3?
yeah. Uh-huh. This is negative.
Negative.
No, you don't. You go down when it's negative. You always go to the right. You never go to the left.
I mean, down 3, over.
2, 3, to the right 4. I'll reverse myself on the other side. Up 3 and to the left 4, and well, this is where they're gonna intersect. See if I go on there. Will I get on there? I might as well extend them since intersect right there.
So there's our spot. Our intersection place is -40. There's our answer. To give your answer is an ordered pair usually. I don't know what way they require it in the homework. But one of some of the things you'll encounter are some odd things. Like, I hope at least you encounter some of them and ask about them next time. But like, the weird situations with lines occur like this, when one is this and one is this. One vertical and one horizontal. They'll have an intersection point, but you'll have to graph it to find out where it is. Another thing that can happen with these lines is this, parallel. Will they intersect? If they're parallel, they will not intersect, means there will be no solution. And then there's actually a situation where they could actually both be the same line. What I'm gonna do is take one of these and use it to do a problem here, but let it springboard us into the next section as well. So what that I had in mind was like number 20. On this first one, can you tell me what the y-intercept is on this first one? 0, 0. That's correct. This one you'll have to solve for y. Took me a little while to get this one done, but I got no solution. Do you know solution?
Parallel.
Parallel lines, right. So let me show you how it works out. Let's draw this out. Start with this guy. Let's get this down. I'm going to show you something also that I did to help me in graphing. I have a hard time when you do this one here, you'll get a fractional y-intercept. I don't want that. So there's a way around that. You could change the scale of your graph to ensure that you can get this in here. So what I can do, I want my graph will look like this. This marking here won't be 1, it'll be 2 or 6. Same with this. I did exactly the opposite of what I.
Oh, you could do the clear lines next time.
All right, so anyways, what I'll do is each of these is 1/2. So this is 1, this is 3/2, and this is 2. Same deal here. 1/2, 1, 3/2, 2. That way, the second line, when you solve this second line here, what I got when I solved it was y was equal to -x plus 1/2. Did you get that when you solve for y? How did you just solve for y?
How about the negatives?
Negative. Oh. Well, anyways, the usual stuff, subtract 4x and then divide that by that 4. This is y equals -x. So with the graph being reimagined like I have. Let's start with y equals -x. I want to get that, I'm gonna get the dots in. So we'll start with this guy up here. The slope is -1. And as we said, it goes through the origin because the y-intercept was 0. All right, and then -1 is the slope, so I go down, well, down 1 to the right 1, down 1 to the right 1, and I keep going like this, down 1 to the right 1. Put my dot here. Similarly, I'll do the same. I'll reverse myself here, up 1 to the left 1, up 1 to the left 1. And I'll put a line through those things. Now, when you solve this, you should already know there's not going to be an answer to the problem. What's the slope of this guy here? What's the slope of this guy here? Also -1. They're going to run side by side. And so then let me go ahead and draw that one in. Put my points in first. All right, so for this second line here, it's still the same slope, but it starts at 1/2. This is why I went through the effort of doing this, so I would be able to solve this exactly. And now I'm going to go down 1 into the right 1. So down 1 to the right 1. Down 1 to the right 1. Remember, these only by halves. I think this is enough for you to see what I'm doing, what's going on here. Come on, get in there. See, it fights me. So when you have something like this, the only thing you can really do is see that they're not going to intersect each other. They have the same slope. So there's no solution to this problem. That's what you write as your answer, no solution. as I mentioned, this does connect to the next section. I personally, I don't like to graph things when they have any kind of fraction like that because I have to either do this with the graph. But could you imagine if I had like 7/12? What I would have to do, that would be just murder. I wouldn't want to do that. So this leads me to 5.2 and another method that you can use to solve these things. And it's related to what you were going to do at the beginning. So I'm going to take this thing again. Let me copy it again. And now we'll do it the 5.2 way. For the rest of this chapter 5, you will not need your note, the graphing. It'll all be done. Yes, algebraically, exactly right. Five point two is called the method of substitution. So in this, when you do it here, it goes like this. Look at this second equation here. I mean, first equation here. See this? What if I took this? I know that whatever y is, it has to equal negative x. I take this and replace this y with this. Okay, so I'm going to substitute this thing here into this slot.
Oh.
So what it becomes then, let me put it over here, what it becomes. I'm gonna get 4x plus 4 times negative x equals 2.
Okay, oh, that's easy.
Right, the important thing now though is how many variables are in my last equation? 2. No, in the last one, I just wrote up. This thing, how many variables are in there?
1.
Only one, just x, correct?
Yeah.
But it started out with 2 variables. We know how to solve them when they have 1 variable. Do you know what this is going to equal, by the way?
Maybe 1.
See, I have 4x minus 4x equals 2. Can you tell me what the left side turned out to be?
It'd just be 0.
Right. It's subtracting the same thing from itself. Now, I don't know about you, but we have encountered, I think, in this class,
That's why it's okay.
no solution,
Yeah.
right? So graphically, it's because of the parallel. Algebraically, it's because that silly answer comes out.
That's it.
So this also gives the same result, no solution. So generally speaking, these problems, one of them is going to look easier to substitute in than the other one. So here, this was the perfect one to substitute into that. I wouldn't have wanted to try to get one of these by itself and plug it back into the other, you understand? So try to make it as easy on yourself as possible. And let me grab you something, try the substitution method. So now use that method to solve this system of equations. Liquid 5pH, okay. You have a solution ready? Yeah.
Oh, yes.
You got both X and Y. Hmm?
Why'd you change that to word? Yeah, all of it's here. See why. This. Take this. Put it to that spot.
You can go back and use either equation to get the value of Y.
That's what I do.
The first one would be the easiest one. You think you got it? Well, let's see, I have to intervene because I want to do one more, at least one more. In this case, you notice it was, Y was completely solved for in the first equation. So I'm going to take this quantity right here and replace that Y with all of that. So the second equation, I'll replace Y with 3x plus 10. Now you have to put parentheses around it. See it? X, Y, you see the Y there? What's the importance about this substitution? It now only has one letter involved, which can be solved. It's negative 5x. Negative 5x, and you know what to do with this, right? It's 3 plus 6x plus 20
equals 14.
So we combine the negative x plus the 6x.
I can positive x plus 20 equals 14. And so x equals -6. Now remember, you need an x and a y. So far, we only have an x.
This is where you can use what y is equal to get yourself the value of y.
Look at this equation back up here. Remember, y equals 3x plus 10. I can replace the x with -6. To get -18 plus 10. Or if you will, -8. So I have an x value and I have a y value. I usually expect the answer to look like this.
Because it is a location on a graph.
Let's do 20. I think I'll end with 20. Now this one, because of time crunch, I'm just going to have to go through it, but I'm not going to fly through it. But we'll take a second to discuss what do you call it? A way of operating here. Notice, take a look at what we have here. First, tell me which of the two letters, X or Y, is going to be easier to substitute. Ask yourself, is either X or Y initially solved for in either equation? The first equation, Y is all by itself, isn't it? So I can take that and plug it into the Y in the second equation. So I'm going to take this stuff right here and plug it into this thing right here. So that's going to become 2x minus, now make sure you put it in parentheses. I'm going to put above it. See, so the equation was 2x minus y equals 5. You see it there? There's y. Now you're going to distribute. So I'm going to 2x minus 3 halves x plus 5 equals 5. You know what? If I combine those x's, what will I get? Boy, 9 halves, 9 halves. This is like 4 halves. Minus 3 halves, it's 1 half. You're adding instead of subtracting.
Oh,
I'll let you guys figure that out later. Because we have 1/2 x plus 5 equals 5. What would you do here?
subtract 5 from both of them.
Subtract 5 from both sides. I think you'll find out that 1/2 x equals 0.
Which equals x equals 0.
Right, that means that x equals 0, exactly right. So I've got half of my answer now. Remember, my answer is going to be this, zeros.
So y equals -5.
Particularly since it's a y-intercept.
Yeah.
Right, now you can use any equation here. Take either of these equations, replace x with 0 and figure out what y is going to be. So if you replace x with 0, you see where y would equal -5?
Yeah.
Or if x is 0 even here, you'll get negative y is 5, but that's y is -5. So either way you slice it, you get a y-intercept for the intercepted. Any questions? All right, good luck on the homework.
Thank you.
Sure.
Where's the homework, Thursday or next week?
Whatever we do today would be to a week from today.
Next week. Today is Tuesday.
Right, today's Tuesday. Let me stop all this stuff. Stop the recording.